Okay, so for this first lesson here on probability, we're going to talk about what probability actually is. Well, first of all, probability in its core idea is that it is a ratio of the favorable events divided by the total events. Okay, so when we are asking about the probability of something occurring, we have the types of ways that that event could occur divided by the total number of events here. Okay, so probability of an event occurring. Okay, so notice how I've written this. We might be used to seeing this like f of x. Okay, this is not the case. Okay, we don't read that as f of x. Okay, but it is the probability of an event occurring. That is the shorthand notation for that. Okay, just as an example of how we could figure out the probability of something, let's say we have a suit from a deck of cards here. We have the clubs here, and if you didn't know, we have 4 suits to the deck. We have clubs, hearts, diamonds, and spades. Okay, so I took one of those suits out, and I said, okay, given that we have this set of cards here, what's the probability of the card that I draw being a face card? Okay, so in order to calculate the probability, what you want to do is count the number of favorable events. In other words, count the number of these guys, okay, and divide that by the total number of possible events that could occur. Okay, so in this here, if I were to pick a card at random, okay, I've got 3 of these guys being face cards. Okay, so I have 3 favorable events. And then in terms of total number, well, we have 13. If you count them all up, we got 13 different cards. So the probability of drawing a face card from the clubs is 3 out of 13. If you've never seen a standard cube before, this is kind of what it looks like. All right. We've got all the whole numbers from 1 to 6 on here. Okay, so it's a 6-sided die with each number being represented here. Okay, so if I said I wanted to figure out the probability, if I rolled the die one time, if I roll it one time, what's the probability of me rolling a 2? Well, we have it being 1 out of 6. Okay, now one thing I didn't mention up to this point, but each of these things right here have to be equally likely. So that's why I said it randomly choosing. If I shuffled them up, closed my eyes, picked one at random, okay, then we have this occurring here, okay? Likewise, when I just roll this, it's going to be a random, it's going to be randomly shuffled basically as it's rolling, okay? And that's each one of these has to be equally likely. So if I have a weighted die, then suddenly the probability isn't fair. This isn't the probability because this isn't a fair die. Okay, so we talked about it being, probability being a fraction here, but I want to reemphasize this, that the probability of an event occurring has some restrictions on it, okay? You can't have more favorable events than you have total events, okay? So naturally, this has to be less than 1. It's not possible to get something greater than 1. So if you hear somebody, answer the question like, what's the probability that you fail Mr. McClellan's test, has something like, 200% probability, right? They're being hyperbolic here because it's not possible for this to be greater than 1. 1 is a certainty, okay? If you have a probability of 1, you know for a fact that it's going to happen. So something like this, you would say, okay, what's the probability that I get a number less than 7 when I roll this die? Well, I have 6 numbers here that work out in that favor out of 6 total numbers, okay? So in this case, it's an absolute certainty that when I roll this, I'm going to get a number less than 7, okay? Likewise, you can't have anything less than 0, right? You can't have a negative possibility here, okay? The worst case that could happen is that no matter how hard you try, you don't get any favorable events going your way, okay? So that is a impossible, okay? This is an impossible event. So if I have this die right here and I say, what's the probability I'm going to roll this 7? Okay, well, it's not possible because 7 isn't an option. Okay, you can't build 7 with one roll of the die. Okay, so probability otherwise has to fall between 0 and 1. You can't have anything greater than 1, and you can't have anything less than 0. Okay, the last thing we need to talk about here is the difference between something being theoretical probability and being an experimental probability, okay? So what we've done so far has all been theoretical possibilities. We haven't had to run any experiments, okay? So with a theoretical possibility, we can go directly and do the math, okay? So no experiment needed. Experiment needed, okay? So for the most part, we can calculate, we know all of the options, okay? So contrast that to an experimental probability, let's say I wanted to know the probability that a student wears red, okay? Wears something red that day. So there's no way for me to know, unless every outfit that they're wearing is equally likely to be worn in a given day, and I happen to know every single piece of wardrobe they would have. So then I could possibly do an experimental, but probably the better chance I would have is every single day look and see what that student is wearing and calculate the number of successes over the total experiments. So there's very often we could verify a theoretical probability with an experimental probability, okay? So if I wanted to, I could take this die and roll it 100 times to see how many times I get a 2. But there's a pretty good chance I should get about, if I roll it 100 times, I should get it about, 16, I think, 16 times-ish. Okay, maybe 17 times, okay, because that's 1/6 of 100, okay? Roughly speaking, that's what the probability would suggest, okay? So if I roll it, let's say, 6 times and I don't get it once, I might say, okay, I have an experimental probability of 0 times I should get a 2. Okay, so there's just 2 ways of approaching probability. One of them is just kind of gathering information. Okay, so we gather info this way. And versus this one, we just do the math. We look at the number of successes and the number of possible outcomes, and we just do the math straight away. This one, we have to kind of gather some information. So hopefully we understand the difference with this. Last thing here, before we close up, we kind of want to say how we can possibly use the probability here to make predictions about possible, projecting outwards, okay? And I kind of just did it with this last problem. I know that the probability of getting a 2 is 1/6. There's only 1 2 on here out of 6 possible numbers, right? Okay. So if I rolled it 100 times, roughly speaking, how many of those are going to be 2? Okay. In order to calculate a probability, in order to calculate the chance of something happening, or the number of trials we would expect to have happen here, we would take the probability and multiply it by the number of trials we're doing, okay? So we'll call those guys trials, okay? And so these should be successful outcomes. Okay? So like I said before, it's about 16.6 repeating, right? So that's the amount we would expect to be successful. Now, is it possible to roll a die 100 times and not get a 2 even one time? Yes, it is possible. I could roll a 5 every single time I roll that die 100 times, okay? But we would expect, this is what we're projecting out, we're expecting this guy to be about 17 times out of the 100.